Okay, so we're going to talk about random variables and expected value, which is just a fancy word for the mean or the average of a random variable, and variance and standard deviation, which we've kind of talked about at the beginning of the year, but we'll revisit them in terms of random variables. So a random variable is a numerical, aka it's quantitative, so it's a numerical variable where each value is associated with a probability. So if we've got a random variable, the first thing to check is that we write down all of the possible values that the random variable can take, all of the numbers, and then for each value, we have to write down the probability that pairs or corresponds to that particular value for the random variable. So when we say something like a probability model, we just mean a table or a graph that has all of the possible values for the random variable and then all of the probabilities that go with the random variable. So a probability model would be, I would just look at that example there. So like for this particular example, there's only 3 values that x can ever be, 10, 20, or 30. It can't be any other number. It can only be one of those 3 numbers. But it's more likely that x is a 20 than a 10 or a 30 because you look at the corresponding probabilities. So that means if x was to happen, whatever x is, like whatever it corresponds to in real life, there's a 50% chance that the value of x would be 20. There's a 30% chance that the value of x would be 10, and there's a 20% chance that the value of x would be 30. So in terms of symbols and formulas, the key idea here is that you got to check to make sure all the probability values add up to 1, because there's a 100% chance that x will be some value when you pick a single x from your population. That's sort of the key. So in terms of the formula, I would write that like this. So this notation might be new. This capital, it almost looks like a scripted E. It's the Greek letter sigma. And in math notation, it just means that you add up. So in math speak, this kind of translates into that if you add up all of the probabilities, they have to add up to 1, which is something kind of that we already know. I'm just kind of putting that in formal math notation. So that's the Greek letter sigma. And whenever you see that, you should think sum, or adding up all the values. Great. So, example 1 asks us to find the expected value. The expected value is just a fancy way of saying the mean, or the average, of the random variable. So the notation for that is the Greek letter mu. So the capital mu, that just means that we're looking for the mean, or the average, or the expected value. All those things mean the same thing. So in order to do that, again, it's basically just expected value. It's another way of just saying that we're going to compute the weighted average for our random variable x. And we've done weighted averages before when we've computed our grades and things like that. So we're just going to multiply all of the x values by their corresponding probabilities, and then we're going to add up all of those quantities. So as a formula, it would look like this. We're going to multiply every x by its probability, and then we're going to add up all of those. So sometimes I see people doing this, which I really like, is just adding onto the table and making a new column that's x times p of x, and just writing the values right in the table. So here that would be 3, and then 10, and then 6. So all I did was I multiplied 10 times 0.3 to get 3, 20 times 0.5 to get 10, and 30 times 0.2 to get 6. And then I'm just going to add up all those quantities. 3 plus 10 plus 6. Sigma just means to add them all up. So 19 is the average of x, is the expected value, is the mean. All those things are synonymous. So let's look at an example. Scroll down here. So this says, okay, we're going to roll a die, and if it comes up 6, you win $100. If not, you roll again. If you get 6 on the second time, you win $50. Otherwise, you lose. So now we're going to create a probability model for the amount you win in this game. Okay, so I need to make a table for my probability model, and I need to make sure that all of the probabilities for each of the corresponding values for my random variable add up to 1. So first thing to do is I'm going to define a random variable. It doesn't have to be x. X is just kind of like the typical variable that gets thrown around in math class, but I can call this random variable whatever I want. So since this game's about winning money, I'll call the random variable w, and I'll say that w is the amount that you win each time you play the game. Now notice, is w numerical? Yeah, because I'm either going to win $0 or I'm going to win $50 or $100. So w takes on it's a quantitative random variable. And for the values of w, they're going to have a corresponding probability, because I'm obviously probably more likely to win 0 than I am to win $100. If I was really likely to win $100, I would play this game all the time. So let's make the table. So I've got w, and I've got the probability for each w. So I'm going to make this table horizontally, even though I usually make my tables vertically, because I just don't have enough space to make the table vertically. So I could either win $0, if I don't win anything, I could win 50, or I could win 100. Those are the only 3 values that I could win in this game. So basically, I need to make sure that when I add up all of the probabilities that I end up getting 1. So I need to now go down here and figure out the probabilities. So if I roll a 6, I win $100. Now I'm assuming this is a 6-sided die, and I'm assuming that the die is fair, meaning that I'm assuming each of the sides is equally likely to occur. So that means that there's a 1/6 chance that I'll win the $100. I roll the die, I get a 6. Great. Okay, so now, how do I win $50? I win $50 if I don't win on the first roll, meaning I get something other than a 6, but then I get a 6 on the second roll. I win the $50. So in order for that to happen, I'm just going to come down here and do a little side calculation. There's a 5/6 chance that I'm going to not get a 6 on that first roll. Then I'm going to multiply that by, because that's got to happen. First I have to not get a 6, and, so I'm multiplying, and the events are independent. Each roll is independent of the die. And then I have to get a 6 on the second roll. I'm going to do 5/6 times 1/6, and it has to happen in that order. I have to not get a 6 first, and I have to follow that up with the 6. I can multiply those probabilities. The events are independent. So that is 5 out of 36. Now I know that all of the probabilities add up to 1, so I could just take 1 and subtract 5 out of 36 and subtract 1/6 and see what I'm left with to fill in the probability that I get a 0. And if I do that, that's 25 out of 36. But I also want to do the calculation to make sure that I end up getting 25 out of 36. So the only way that I lose this game if I don't get a 6 on the first roll, and I don't get a 6 on the second roll. So that would be no 6. There's a 5/6 chance of that happening. And then same thing on the second roll, independent events, so I can multiply the probabilities. There's a 25 out of 36 chance that I win nothing. And if we check, all all of the probabilities do indeed add up to 1. Part B is asking us to find the expected value. That's just the mean. So I'm going to find the mu of W. Make sure you're labeling this right. So I'm not going to write mu of x because I didn't call my random variable x. Then I need to find the expected amount that I win. So I'm just going to add up all of the W values multiplied by their corresponding probability. And I don't have room on my table to make another column, so I'll just do out all the math right here. So that's 0 times 25 out of 36 plus 50 times 5 out of 36 plus 100 times 1/6. And that is going to work out to be, so that is $23.61, rounding to the nearest cent. That is the expected value for the game. So for these problems, you should, I'll put the PDF of this worksheet obviously right next to the link for the video. So try these on your own, see if you can figure out what the expected values are after watching the video. And if you do that, you should find that for this first one, the expected value of x, I'm not going to put up the work, I'm just going to put up the answer, is 1.2. And for number 2, we didn't give a name for this random variable, so I'll define it right here. Let's say that G is a math test grade. Math test grade. So we're finding the expected value, so mu of G. And if you did that computation correctly, you should have gotten 73.8% is your expected value for your grade on the math test.